In the last few videos, we've talked about different ways to run code over and over again, and in this video, we're going to talk about recursion. So what exactly is recursion? Essentially, recursion is just a function that calls itself. And this may seem kind of confusing because you'd think that would create an infinite loop. For example, if we had a function called print, let's just say print hi, and all this function does is say console.log hi, and then it calls itself print hi. Well, what's going to happen is if we call print hi, it's going to log out hi, and it's going to call itself again. Log out hi, call itself again, log out hi, call itself again, and it's going to do that over and over and over again. Now, if I were to call this function, it's going to loop forever, printing out hi over and over again, and eventually I'll get a Stack Overflow error. But since logging to the console is really slow, the easiest way to see this is if I just remove this log completely and just run print hi. And you're going to see what's happened. If we save, you see we immediately get an error and it says uncaught range error, maximum call stack size exceeded. And if you remember earlier in the course where I showed you the call stack and how you can see all the functions that are called in order of them being called, well, the recursive function, we're calling the same function over and over and over again. And eventually we're calling this function so many times that the call stack, that list of functions we've called to get to where we are, became so large that the computer can't actually handle that anymore. And that is what happens when you exceed the maximum call stack. As you can see, it has a ton of different print hi functions being called because we're just calling the same function over and over and over again. But this is the idea of recursion. Recursion essentially says, I'm going to loop through things, but I'm going to do it inside of a function instead of doing it inside of a normal loop. So let's just get rid of this and write out a normal loop for printing the numbers between 1 to 10, for example. So all we do is we just say for let I equal 1, while I is less than or equal to 10. And we're going to add 1 to I each time, and we're just going to console.log I. This right here is going to print 1 through 10. Okay, that's pretty straightforward. This is really obvious, and this is a great example of how to use a for loop. So how would we do this with recursion? Well, we would need a function, so we're going to just say function here. We're going to say print number, and this is going to take in a number. And all that's going to happen in this function is we're going to say console.log, and we want to log out our number. And for example, we would call print number with number 1 to start, as you can see here. If we just comment this out, you'll see right now this just prints the number 1. But we want this to call itself again with the next number we print. So what we're doing is essentially we're having our let I equal 1. That's the initial call of our recursive function right here, where we pass in 1 as the number we're printing. Now the next thing we need to do is in order to increment our number and recall it. So that's this third portion of our for loop. So we would just say print number of number plus 1. So we're calling this function again with the next number in line. So that's this section here. And then finally, we need our stopping condition. So all the way at the top here, we can just say if number is greater than 10, essentially the opposite of this condition, because if it is greater than 10, what we want to do is return. You could do this the opposite way where it says less than or equal to 10, then we actually run this code inside of here. That would work as well. But generally, I like to return early instead of actually put everything inside of an if statement. I just find this to be cleaner. So if our number here is greater than 10, we're just going to exit out of the function and no longer call it again. Now, if we save, we get 1 through 10 being printed out. But you're probably looking at this and thinking, what the heck, this is really confusing. And you are correct. In this scenario, recursion doesn't really make sense. It's so much easier to do with a for loop. But this is great for understanding how recursion works. So as you can see here, what happens when we call print number is we pass in 1. So we have 1 here as our number, and we go down, we say, is 1 greater than 10? Nope, okay. So we log out 1, and we call print number again with a new number, which is just our current number plus 1, so 2. Come in here, is 2 greater than 10? Nope. So log out 2 and call it with 3. We do that for 3, 4, 5, 6, 7, 8, 9, 10. Finally, we get to number 11. So we call this with 11. It says, is 11 greater than 10? Yes. So we return from this function and immediately exit out of this function. We don't run the code down here. Then what happens is we go back to the previous call of our function, which is right here. It's at the end of the function, so it returns, and it does that all the way to the end. We can actually see this if we just say console.log exiting function. Now what you're going to see is we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 printed, and then we get exiting function being printed a bunch of times. And that's because when we get to this return here, we return out of the function, which means we go back to our previous call of the function right here, and we continue on executing our code, which is logging this out. Then we exit that function and go to the previous one, and the previous one, and the previous one, and the previous one. We have to go back up that stack trace. Think about it this way. We're calling all these print number functions, And our code stops right here when we call this function and then runs everything inside of it. Stops when it gets here, runs everything inside of it and inside of it, inside of it. And eventually we need to go back outside of the function. So when we return from here, we start down here at the return of print number and run this code. And then again, and again, and again, that just happens over and over and over again until we get out of that call stack, essentially done with all of these print number functions that are stacked on top of each other. It's much easier to see this if we were to just change this to 2, for example. So now if we save, it prints out 1, 2, and then exiting function, exiting function. I'm going to walk you through step by step exactly what happens. So we call print number with 1. It comes in here. 1 is not greater than 2, so we continue. It logs out 1, and we get to print number plus 1. And that's just going to call print number again. So we stopped. We immediately have stopped executing right here. And now we go into a new print number. This is a new version of this function, essentially, where number is now 2. 2 is not greater than 2, so we log out 2, add 1 to number, so it's 3, and again, we stop right here. So now we're up here in our third version of print number, where number is equal to 3. And we return immediately because 3 is greater than 2. And when we return, we go backwards 1 step to where our number was equal to 2, right here, where we stopped before, and we continue executing, where we exit this function here. We call this console.log exiting function. You can see that prints out over here. Then this function ends, and we go back a step again, where we had number equal to 1, right here where we stopped before, and we again log out exiting function. And then once that's done, we then go back a step further. And back a step further means that we go to the code directly after where we called print number 1. So if we just put console.log end here, you can see that gets printed all the way at the very end after all of these recursive function calls happen. So now let's modify this code slightly to take advantage of recursion. Let's take this loop up here, and instead of just logging out I each time, I want to get the sum of all the numbers between 1 and 10. So what we can just do here is say let sum equal 0. Then we're going to say sum is equal to sum plus I. And then down here, console.log our sum. Let's just get rid of all this code down here. And if we print, you can see we get 55, which is the sum of the numbers between 1 and 10. This is how you would do this with a for loop. It's not too much code, it's not too bad, but we can do this with recursion as well. So let's create a function. We'll just call it sum number. We'll actually call it sum numbers below, just like that. And we're going to take a number here. And then we're going to call sum numbers below, and we're going to pass in 10 because we want to get the sum of all the numbers, including 10 and below. So to do this, we need to take advantage of the fact that we do those returns. So all we're going to do here is we're going to take our number, we're going to add it to the same call of sum numbers below, but we're going to call it with 1 less. And then we're going to return this. And then if we just log this out here, you should see we get the exact same result. So if we just comment this code out up here and save, of course we actually get an error. It says, maximum call stack exceeded because we didn't put into this an exit scenario. We could just say if number is less than or equal to 0, then we want to return 0 because that's like our initial case where we set sum to 0 here. This is our initial case in this scenario. So now if we save, we get 55 being printed out. And you're probably looking at this and you're probably even more confused than before because this code is quite confusing. Let's kind of walk it through where we're just going to do an example where the number is 2. And you can see we get 3 being printed out. So what happens is we call sum numbers below with 2. Our number here is 2. Is 2 less than 0? Obviously not. So we come down here where we take 2 plus whatever the return of sum numbers below with 2 minus 1 is. So now what happens is we get to this point and we again stop our execution and we call this function. So we recall this entire function, but now number is 1. 1 is not less than or equal to 0. So we do 1 plus whatever this returns when we pass in 0. So we again stop, call this entire function again, and now number is 0. So we return 0. And that means that we get to this portion of our code where we had stopped previously where number is equal to 1. So we do 1 plus 0, which is 1. Now we go back a step further where number is 2. And what we're doing is we're taking 2 plus the results of what we had before, which is 1 plus 0, which is 1. And that's where we're getting 3 because 2 plus 1 is 3. And then we're exiting all the way to here where now our value is 3. And it's just console logging that out. Same thing is going to work with 3 or 4. 4, 5, doesn't matter. We save. We're always going to get that sum. And this is kind of the power of recursion. We can do some really complicated things with it. But something interesting to note about recursion is anything you can do with recursion, you could do with a normal for loop, just a normal iteration like that. So recursion is not something you're going to see super often, especially because it's really easy to accidentally create an infinite loop with recursion because you forget to put the condition in here just like I did, and then you get that error for exceeding your maximum call stack. So this is why I generally don't recommend using recursion unless you have a really strong use case for it. And generally, it's just easier to use a for loop to do certain tasks that you could do with recursion, or you can do it with a while loop instead. Recursion is one of those things though that you're going to get asked about all the time on interviews, so it's important to understand how it works. So I actually want you to do an example. What I'm going to do is I'm going to use the example from previously where we had a person with a name, in our case Kyle, and a friend. They have a name, we're just going to call them Joe. They had a friend, and this friend has a name of Sally. And you know that we can use a while loop where we just say current person is not equal to null. Default our current person equal to that person object. And then in our while loop, we're just going to log out our current person.name, and we're going to set our current person equal to the friend. We're just going through this friend list. We did this in the last video. If I save, you see we get all the friends' names being printed out, starting with our main person and working our way down. Now what I want you to do is convert this to a recursive function where you pass the person to the function. You're going to print out the name inside of that function, and then you're going to get that person's friend and continue that all the way down until you get to the very end where there's no more friends and you exit out of the recursive function. So I want you to essentially create a function called print names. It's going to take in the person just like this. And I want what this function to do is actually loop through all the friends just like our while loop does and print out their name all the way down until there's no more friends left. So pause the video here, try this out yourself, and I'll show you how to do it. Okay, so hopefully you've had a chance to try that out. So let's create this function, print names, which is going to take in our current person. There we go. So what we first want to do is to create an escape hatch, the thing that's really easy to forget about. We're going to say if current person is equal to null, then we want to exit out. So we're going to do a return here. This is our safety hatch. That way we always make sure we exit out of this function. Next thing I want to do is the meat of our function, which is logging out that person's name. So we're going to log out their name. Then finally, we need to recall this function with the friend. So we can say print names of current person dot friend. There we go. Now if I save this, you'll see I get the exact same results. Kyle, Joe, Sally. It's going through everything exactly as I expect. We get Kyle in here first. Kyle's not null, prints out the name Kyle, and then gets Joe, which is the friend. We go back through here with Joe, and then we go back through here with Sally, and finally, Sally doesn't have a friend, so it goes through here with null, and of course here we get this current person is null, so we return, and then exit out of all the functions in order, and then finally exit out of our entire program. And that's all there is to recursion. It's a fairly complex topic, but as you use it more and more, it'll really start to make sense exactly where you need to put all the different variables in order to make a perfect recursive function. Now in the next video, we're going to talk about another really kind of interesting topic, which is short circuit evaluation, which is something you will see all the time in JavaScript. So it's really important you understand exactly how it works. I can't wait to see you in that video.